Yeah, hello everyone. This is the part two of our binary tree series, and this video we're gonna solve the question number 572, subtree of another tree. And okay, so question is in the front of you. You can read the question. Uh, Here we given the two roots of our two binary trees, root and a subroot. You can see three is a root here, and subroot is four from the next tree. If there is a subtree of a root with the same structure and the nodes value of a subroot and false otherwise, okay, you have to check if the subroot is a part of the original root or not. Means if you suppose, let's suppose it is a q, okay, this is q and this is p. So if the q is a part of a p or not, the main question is this: if the q is a part of p, you have to write the true. If not, if the q is a not part of the p, you can write a false. But there is also one catch. If subroot is a, you have to check if the subroot is completely part of the queue. Like in this example 2, you can see that subroot is obviously the part of 2, like 412 and 412, but here 2 have a left node, but in the subroot 2 doesn't have any nodes, so there is a no chance of this root is a, a part of the this root. According to the question, we have to match the subroot as a part of a root. Like in the input we see the 3 4 5 1 2 null 0 0, and in the subroot part 412. So obviously this is not a part of the root. And in the example one we see the 3 4 5 1 2, 3 4 5 1 2, and the subroot 412. So yes, 412 is a part of this. So we write the question, output true. And this is the simple question, and we need to write the code. The code is not too much complex, but you have to understand that what I say. Okay, so I write the code earlier for you, for the better case to understand. Like if I write the code, the video takes around 10 to 15 minutes, and I also feel hesitate to just explain you that what I write, and it's take a time. So here in the function is class solution. Okay, the function is identical. We have to check if the p and q is identical or not. If they are identical, or if the part of some nodes are identical, then we can say that the yes, this we can run in the right way for solving this question. So p equals to null or q equals to null if, you see, if p and q the both are null, then we have to return the true. Obviously they both are identical now. Then we write return p equals to q, and return p value is equals to q value and is identical p left q left. These are the, if you see, this code is the same, similar as the same trees code, okay, which is the, I think the problem number 100 at LeetCode. And after that we can check the condition. If the p and q both are identical, then we write a boolean which is some function name subtree, and in the subtree we write a node root and another node subroot, which is the another tree, or we can say that the part of the root. So in this function we write if our root is null and subroot is null, then we can say the root is equals to subroot, as a as I say earlier in this function. Then after we say that if the root value is equal to subroot value, like in the first case 3 is equals to 4. No, it's wrong. 3 is 4 equals to 4. So here is a root node and subroot node, both are equal, so is identical root equals to subroot. So root equals to subroot, we have to check is identical value. It's recursively check the all the cases which is written in the form of trees. So okay, the root and subroot are iterating in this form. These are, firstly we checking the null values, and then we attach the p value and key values, and both the left and the right nodes of the problems or of the nodes. And then we can recursively return the subtree function for the left and the right part. If we see the 4 and 4 are equals, then we also have to check the if the value of the left side and the right side equal in the both the cases, then we can say that now a subroot is a part of the root. If the left and right values are not equal, then there is a no chance of to write this code in the this manner. So after returning is subtree root left subroot and is subtree root right subroot. These function is a one of the important for checking the both the left and the right cases. And as we see in this 3 1 3 4 5 1 2 and subroot 4 1 2. So here we write true. and this function is a a recursively iterate. We check each function, after checking 4 we checking 5. If we not, if there is a no 4, let's suppose the if we see the here, uh they can see here is a 3 written. Okay, so 3, after that 1, after that 2, and if the 2 node is the 4, then we can say that the 4 is a a match with the subroot node. So this is the catch, and you need to just focus on these topics. And this is the code, and let me run it again. Okay, yes, this code was accepted, both the cases accepted. And so here's the code you can see, and I hope you understand also the code. So okay, so we need meet in the next video. Let me submit it also. Yeah, it submit successfully. Okay, so meet you in the next video. Bye.